Hey everyone and welcome back. Now in today's video we'll be discussing about the RPC encryption with TLS. Now similar to earlier video where we have seen on how client makes use of a gossip protocol for communication. So when you discuss about a communication between console client and server, it primarily goes over the RPC on port 8300. So here you see that client sends the request over the RPC on the port of 8300 of TCP. So for example, whenever you request some data over a key value store, so with the help of CLI command like consul kv get on a specific key, so that data travels via the RPC to the server and server responds back over here. So what would happen here is that by default the data that would be traversing would again be in a plain text. So this is one of the dump of a RPC based communication where you see lot of data is available in plain text. So if a attacker is monitoring the network, he can get a lot of sensitive information, specifically if things are over RPC. Now we already know the solution. The solution is to go ahead and enable encryption. However, to make this lecture more interesting, first let's go ahead and send some data over the RPC between client and server. So that data, let's call it as a sensitive data, and then we'll look into how we can capture it over the TCP dump. So currently I'm connected to console. Let's go to key value over here and let's create a new key. Let's call it as sensitive data and let's say password 123. I'll go ahead and do a save. So now from the console 01 instance, let's quickly run a TCP dump on the interface of any. We'll use the port of 8300 with a verbose over here. And also from the console 02, first let's quickly verify if the connection is working as expected. So we are able to see the members. So now let's do a console kv get and the key here would be sensitive -data. So let's try it out. So as expected, we are able to see the password. So now let's quickly go ahead and run the TCP dump over here. So once done, let's go ahead and do a console kv get and I'll do a control C. So as soon as we did a console kv get, we got this specific sensitive data. So this sensitive data is something that we can also see from this specific dump over here. So let's go a bit up. So here you see within the value you are able to see password 123. So in case if a KV is storing some sensitive token or any other data with the RPC, if a attacker is monitoring the network, he can easily get all the data that is being communicated over the RPC here. And this is the reason why not only encryption over the gossip is very important, but also the RPC is quite important for production environments. And in today's video, we'll look into how we can go ahead and enable TLS for the RPC encryption. Now, when you discuss about the RPC related encryption, there are three primary steps that are involved. Now, do note that this works based on TLS. So first is you have to initialize a inbuilt certificate authority. Second is you have to create a server certificate. And third is you have to configure the server and client configuration file. Now discussing about the certificate authority. Certificate authority is an entity which issues a digital certificates. So let's assume that you have a certificate authority and this CA can issue certificates for server, for clients and so on. And also one important part to remember is that both the receiver and the sender trusts this certificate authority. So for example, let's look into the certificate authority associated with the docs Google. So when you quickly look into the certificate here, you see that this certificate is issued by a specific CA. And this specific CA in turn is trusted by my Google Chrome browser. If my Google Chrome browser does not trust that CA, then you would not have received the green mark. Similarly, let's open up the DigitalOcean console. If you look into the certificate over here, this certificate is issued by Cloudflare. And if it is trusted by my Chrome browser, then only you will be able to see this communication over the green symbol. Similarly, if you have a certificate authority, then both the server, because both the server and the client will be communicating over the TLS, and both of them should be trusting this certificate authority that will be issuing the certificate. Now do note that this will be a private certificate authority. So the step 1 is you can go ahead and initialize the built-in certificate authority that is available. So again, there are multiple options. So you can either use a built-in CA, or you can also make use of a third-party private CA in case if you want to. You can even create certificates with OpenSSL and so on. So we'll keep it simple. We'll be making use of a built-in CA. So the command to go ahead and generate the CA certificate and the CA key is Consul TLS CA create. So in the output you get the CA certificate and the CA key. So this is nothing but this CA certificate and the CA key that you see over here. Now once the CA certificate and the CA keys are created, the step 2 is to create the server certificate. So to create a server certificate, the command is simple, Consul TLS cert create -server. So this will go ahead and create the server certificate and the server key. So if you look into the diagram, you have a server certificate here and you have a server key. So this is been issued by the certificate authority that we had created in step 1. Now once the server certificate and the key have been created, the next step is to go ahead and configure the server and client. So you have to add a specific configuration both at the server level and the client level. So in the server level here, you are referencing to the server certificate in the cert file. In the key file, you are referencing to the associated private key, and then you are also associating the CA_ file, which is nothing but the certificate of the CA. And the same thing you also have to specify in the client, where you have to specify CA file and you have to direct the CA certificate file. So let's do one thing. Let's jump into practical and initialize things step by step. So let me quickly go to etc consul.d directory, and we'll keep it simple. We'll go ahead and remove the older files like agent.hcl that we had created earlier. So first step, let's do a Consul TLS CA create. As expected, there are two files that have been created. So if I do ls-l, you should see a Consul agent CA key and the Consul agent CA. So these are nothing but the certificate authority certificate and the certificate authority key. Now the second step is to go ahead and create the server certificate. So I'll say Consul TLS cert create followed by the server. So this should go ahead and create a certificate for the server and the key. So if I do ls-l, this is basically the server certificate and this is basically the server key. Now the step 3 is to go ahead and configure both the server and client. Now one thing that is common across server and client is this CA file, which is nothing but the CA certificate. So we have to copy this CA certificate from server to our Consul client. So let's quickly do that. So let's quickly do a base 64 and the input would be the Consul agent ca.pem. So you have the base 64 output. Let me quickly copy this up. Now I'll go to my client. Let's quickly go to a temp directory and let's create a file called as temp.txt. I'll paste the base 64 here. Now let's quickly do a cat here. We'll do a base 64 decode and I'll store the output in etc consul.d and the file name would be the same, which is consul-agent-ca.pem. That's great. So if you quickly do a cat on this, you should see the certificate file here. Great. So now since the certificate are added both in the server and the client, let's go ahead and add the appropriate configuration. So within the server, let's open up the consul.hcl file. We'll remove the older encrypt parameter which is used for Gossip Encryption. And from our nodes, we'll go ahead and add the configuration here. So if you'll see here, you're referencing to the CA file. In fact, it is always better to reference to the full path, which is etc consul.d Consul agent CA. You're referencing to the server certificate, you're referencing to the key over here, and you're also enabling the auto encrypt. We'll be discussing about auto encrypt in just a moment, but first let's go ahead and copy this up and let me paste the contents. I'll go ahead and save it. Also make sure that if you have created the certificate, make sure that they have an appropriate permission of Consul. So currently these certificates are generated with the root user. So you can quickly do a chown on this directory, so all the files will have the Consul related permissions. Now let's quickly verify if Consul is up and running. So currently it is running. So let's go ahead and restart the Consul. Let's verify the status. Our status is running as expected. Now within the Consul client, let's quickly go to etc consul.d directory, and again we have to modify our consul.hcl file. Let's remove the older encrypt parameter, and here for the client configuration, we'll reference to the CA file will also have a auto encrypt. So let's copy this up. I'll paste the contents. And also one more thing, as we discussed, it is always better to reference to the absolute path, which is etc consul.d followed by the CA file. Also to verify the permission, so for this the permission is root. So let's quickly do a chown, and if you do ls-l, the permissions are correct. So now let's do a systemctl restart Consul. Great. So let's quickly verify the status of Consul, and it is running perfectly well. So to verify if things are really encrypted between the RPC, let's go ahead and run the TCP dump yet again. And within the Consul client, we'll say Consul kv get sensitive data. So the data is retrieved. However, within the packet, so here you see all of the plain text data that we used to see earlier, everything is encrypted. You are not able to see any contents within the plain text. That's great. So not only we were able to achieve a gossip level encryption in the earlier videos, but we were also able to encrypt the communication of RPC with the help of TLS. So if a attacker is monitoring any traffic, be it gossip or be it via the RPC, all of the traffic is encrypted and he'll not be able to get any data in plain text. Now there are a few more important pointers that we should know related to the methods of distributing the certificate. So there are two primary methods of distributing the client certificates. So if you remember that in today's video we had generated the server certificate, but we never generated the client certificate. So what happens is, based on the method, the approach would differ. So there are two methods, one is the operator and second is auto encryption. So if you're making use of auto encryption, you can configure the Consul server to automatically distribute the certificates to the client, and that data would be stored in memory. So this is automatically done for you. However, if you choose to have an operator method, then you will have to generate the certificates manually. And also if you are making use of a third party certificate authority, then the operator method will be a better choice, and it also gives you a better flexibility there. That's great. So I hope at a high level overview, you understood the basics of RPC encryption with TLS.